Welcome, everyone. Welcome to today's Innovation Coffee. Robert, what's the title today?
Hello. Yeah, great. Good morning, good evening, good afternoon, everyone. So today's title, Hardware Design 101 with Michael Welling. And we're going to be talking about basically taking your idea to product, designing hardware, and we get the inside look. We get the inside look of the mind of a serial hardware designer. I worked on that a little bit.
It's those rare people that actually manage to do everything themselves. I mean, I'm
basically. Very exciting.
I'm really excited. I've got loads of questions. How many questions do you have?
Gosh, I don't know, 10? It is cool because I've been sitting in various channels and seeing people design hardware. There's these discussions around Geppetto and these kind of more let's call it streamlined ways of designing hardware. But we're actually going to speak with someone who has been doing this for a long time, using the I want to call them like the real hardware design tools that you'll see in industry. And it's exciting because we're going to walk through everything from all the way like I said, from the idea to getting your product out on the market. And this is something that our guest has done several times. So it's cool.
Yeah. And I mean, the show is called Hardware Design 101 today, but I mean, we're talking to an expert. So if you've got any questions, get them ready because I think there's going to be a lot of time for answering those. So really excited about this. Robert, do you want to invite the guest in?
Yeah. All right. So cue in, Michael. What, do I hit a button? All right. 1, 2, 3. Button in.
Right.
There you go.
Hey, Michael.
How you doing?
Welcome. Good. How are you?
Good to be here.
Really excited. Really excited to have you on the show.
Got my coffee.
Yeah, you want to give us? Oh, you got the coffee. Well, let me see that mug. I didn't see that before.
Do we cheers?
It was from a couple of years ago. Actually, the scale is almost wiped off from the red is staying on there, but the scale logo. I've used this cup so many times that it lost its print on it.
Lost its scales.
Yeah, awesome conference. So yeah. I keep drinking with this cup, and it's just a cup.
So I think in tradition, we're bringing someone foreign onto the show. Michael, maybe you can give us your origin story, right? Like we want to know about you, who you are, where you come from, what's your background, experience. Build the credibility.
Sure. So I'm an electrical engineer by education. I went to university at Southern Illinois University, got my bachelor's, master's there. I actually did all but dissertation in the PhD program there. The first 2 times I graduated with when I graduated with my bachelor's, it was during the first big recession, and it was recessionary, so it wasn't a great time for jobs. Of course, it was SIU, so they weren't knocking down the doors. And so I just continued with school, lots of school. VLSI mostly. I did a lot in the computer engineering degree, more than electrical. I was a computer engineer. But towards the end, I started focusing on mixed signal, analog, the whole thing, essentially computer architecture from the beginning. And when I graduated or a master's degree, I didn't really have a good job, so I came back to school. But not too long after that, I needed more money than the graduate assistantship was giving me, so I got a job at a company called EMAC Inc. in Carbondale, Illinois, and they're a small SBC company that designs ARM single board computer system on module. And I started out there doing kernel board support for their boards, and I took to it so well that I kind of quickly grew in the company to doing pretty much all of their board support after hands changed and engineers left. And I was doing board support for pretty much majority of their ARM product line. Then I also at the same time learned printed circuit board design there. They're a board design house plus a manufacturer, so I was there like right across the building from the assembly line. So I got to learn how the assembly process works, how the procurement process works, how the prototyping process works, pretty much everything.
So you started off. So you started off really as a software. Well, you started off as actually as a hardware engineer in school, right? And then you kind of did your first job when you were working on kernels. So actually, kind of looking at more the software stack rather than the hardware, and then you kind of gone back to the hardware afterwards, right? So it's a bit of back and forth.
I've always been a balance of the two, actually, because I was originally considering computer science when I started school, but I went on to do electrical engineering. But I took probably, by the time I was done with school, I had almost a bachelor's degree in computer science, maybe even close to a master's degree, considering how many courses I took in computer science. So yeah, I always kind of rode the line a little bit because I knew that having both skills was something that would be extremely useful in the future. And you know, I got ideas in my head from certain professors that if you can do both, you could rule the world, or you could, you know, and a larger salary. And I was like, oh, okay, I'll do that. And you know, computer engineering has a lot of programming involved in it. So yeah.
And I know people might be looking at you and thinking, oh, you know, he looks kind of young. But you've been doing this for decades, right? I mean, like you've been in this industry at least over a decade, doing this kind of stuff, right?
Yeah, I'm 41 now. So like I've been into the design and PCB design and software firmware for over 10 years.
Yeah, this is awesome. Yeah, so I mean, I can already see some questions popping up in the YouTube, but I think we'll maybe hold off on those for just a second, Alessandro.
Sounds good.
Okay, cool. So Michael, thank you for that introduction. Very, very nice for you to share all that stuff. I want to kind of move into at least this, the big picture of this hardware design 101, right? Because again, like mile high view, we're looking down on, you know, again, starting with an idea and moving forward into getting your product out there and sold to someone that you don't know, right? So this is the two endpoints, right? Can you just walk us through this mile high view of idea to product, you know, whatever those milestones are?
Okay. So usually it starts with an idea, and the ideation phase is it's a big deal. Once you have that light bulb moment, you got to make sure that it's not, you know, just your head's gone crazy, and it actually has kind of legs. So before you really dig into a project from the ideation phase, you want to do market research so that you don't end up creating something that isn't really needed out in the world. So you'll go out there and you'll say, okay, does it exist? Probably. Does it fill like kind of a need? Probably. And then, you know, if after that, once you figure out, hey, this thing can actually go somewhere, you say, okay, maybe put some teasers out there, say, hey, I'm considering doing this. You know, of course, people are going to be jumping on the ideas. The industry is full of copycats, essentially. But then if you have enough eyeballs, you just like it looks like a good idea, you can start doing production. But it usually starts with a prototype, right? And the best way to do that is find something that has maybe a similar hardware architecture or structure, a chip that really fits the bill, or something that would implement it quickly with, you know, various pieces slapped together with wires. So you have a early proof of concept. And once you have that early proof of concept, you can do initial firmware development, you know, realization, you know, whether or not it's going to work, you know, and sometimes ideas just don't work. So that early prototype will say, okay, I've passed checkpoint, you know, 1 or whatever. I got this early prototype. It works. What's next? And those
Can I pause you a second for the You mind if I pause you 1 second on the what's next? Because
Okay.
I'm curious about one thing.
Okay.
How do you come up with the first idea? Like, how do you come up with something innovative or something that is serving a need? I think that's really interesting because you said that, right? You said you need to serve a need of the user, right? So that's like one of the points that you raised. How do you know what are the needs? Like, what is your process to finding out the needs?
Yeah, I kind of troll the community. I look out there, see what people are asking for. I talk to people at conferences, say, hey, what's out there, what's needed. Usually it's something that fills a need for yourself. You need a specific piece of hardware that doesn't exist in the world, and this is always going to be something that will have a little bit of legs because you're not the only person that has that problem. I mean, like for consumer ideas, you just talk to like anybody. Everybody's got a consumer idea for me, but for like industrial IoT or something that you need for testing or something that an engineer would want is a totally different thing, like a logic analyzer or something like that, some test equipment. So really what I would do is like you're working on a project, you say, I really could use this auxiliary piece of hardware to help me along. That's probably a good idea. It might not have as big of a market as say a consumer product, but then you don't necessarily have to target that market. You don't have to go crazy and say, I want to make this, million piece thing. You could make something that'll fill a need for a subset of engineers. Essentially, you could make something that maybe takes, helps out gamers. Say you want to add some kind of AR feature to your gaming or something, and people come up with these ideas while they're just every day, coming like experiencing things, and it's just a matter of some people are good at it, and it just comes to them. They're inventive. They have a creative mind. Some people have to work at it. They have to have somebody else there for inspiration, maybe. And it's good to hang around with people that are creative and have like kind of a crowd of like people that are creative around you does help a lot.
I like this comment from iShot JR on the whole idea theme is, necessity is the mother of invention. And I think that's, you touched on it, right? It's like your ideas kind of come from the things that you may just need. Like you're walking through the kitchen and you realize you're out of milk and you're like, what the heck? How did I run out of milk? Right. And how did I let this happen? Maybe I should create some device that tracks the milk in my refrigerator. And so like, these are these like little things come out. Right. But on that note, right, before we, go back to, I think we were like maybe halfway through that on the way to manufacturing or production and whatever. iShot JR does bring up one thing here. How do I click on that one? Let's see. He's like, Michael, when you refer to the community, so when you're, going through your market research phase, so you have your idea and you want to start prodding the community or you're trying to come up with an idea and you're working with the community. He's curious. Maybe you can give some pointers on or some key communities that you think are valuable that people can go look into for ideas and or market research.
Yeah, I'm pretty bad at social media, but I used to do Google Plus. Sadly, that thing went away. And there was a lot of Linux nerds on that one, and I used to show off my boards on there, and people would give comments. When that died, I started using Twitter. And Twitter, it seems like a good place to pick up hardware nerds. There's lots of them out there. Lots of PCB designs, lots of silicon views and stuff like that. So when you're out there, that's a great one. Twitter's good. Hackster and Hackaday are good. Yes, I use both of them. I work with both platforms. They both have their kind of limitations. Hackster is more of it's a one-time kind of expose of your project, or it's just like a log. But Hackaday, you can actually have like day-to-day kind of digest of what you're doing along the way of the project, which is a little nicer sometimes. For industry forums, yeah, there's like, I don't know, the EEV blog, maybe. Although that one I don't really spend time on. I don't really do a whole lot of digging through forums, honestly, because I find I have enough to deal with. If I want to look at forums, I do my day job essentially. You're always looking through the different things. So what I usually do is I go out, like, if before the pandemic, I used to go to conferences a lot too. I used to attend the Open Hardware Summit, the Embedded Linux Conference, the ARM TechCon was the decent one I went to. I think I met both of you there, or one of those two, the Maker Fairs. I mean, it really depends on your target market, where you want to look. So if you're making test equipment, people are like out on the net, like generic design people won't be as interested, but there's probably a core group somewhere. Or if you're doing like this wristwatch thing, then it's like just put it out on Twitter and get feedback essentially. So it's hard to get quality feedback from Twitter. People are like, I just want more features. I want this, and this, and this, or I don't get any feedback. They're just like, they press the like sign or the likes button, and I don't know what they want. I don't know what anybody really wants.
Yeah.
It's a matter of putting it out there and making it available. And if, like, I find that if you don't have a good idea of its like efficacy or its ability to fly in the market, you can do test runs using crowdfunding type situations, and we can talk about that further on. I've used crowdfunding.
Yeah.
That really helps because it could fail and you don't lose anything.
Yeah.
And that's why I like doing it that way.
So that's awesome. I hope that answered I shot JR's question. But so let's, if we could, move back to that big picture view again, right? So we started off with the idea. The idea moved into market research, which we were just kind of discussing more in depth right now. After the market research, then you kind of source some parts and build your prototype, maybe at a base level. Then you went on, I think, to talking about writing some firmware.
Yeah, it's always good to do initial firmware tests and kind of big picture, like, is it going to work things. Most of the time it will work, like anything that I usually work on, but sometimes they can be crazy ideas, and those need more upfront kind of legwork. You have to really put the time in to do the firmware. A lot of times you can find these system on chip eval boards and wire things into it and test everything you need.
That's your prototype. And then you get the BOM, you get the bill of materials, and then just kind of work from that.
Yeah. And you don't necessarily even have to use the same chip. It could be a variation of the chip. It could be totally different manufacturer, but it's better to use what you're prototyping with, but it's whatever fits the bill essentially.
That's a nice little shortcut, right? So like if you already intended maybe on using a certain SoC, you kind of knew what components or at least what you were trying to build, you just go find a board that already exists, plug the things in there that you are interested in adding to it, and then from there you're like, okay, this works. Now I want to go source my rebuild kind of thing, right?
And it's important when you do that to actually find something that has schematics and bill of materials available for it, at least schematics, so that you can actually use the design. I mean, if you get something and it's like, okay, I've made this prototype, but now I have to sign an NDA, I have to do all this crazy stuff to get a reference design, it's not very fun.
Yeah.
And most people don't want to deal with that. I mean, I'm a contractor, so I deal with it, pretty regularly, but like a new inventor or somebody that's making a community design is going to want to do that. They rather have an open hardware design. And a lot of the stuff that I'm talking about here is my open hardware flow, essentially, things that I do on the side.
Okay, so now you've kind of tested it out. You've gotten your prototype. Let's close out on this. Let's close out on this timeline here, right? So now what's next? You want to source for actually building your final product now. So what's next?
Well, before you get to sourcing anything, you have to actually schematicize and lay out the design. And if that's not something that you can do, you might have to actually do some learning. And then say if you're into, KiCad, which is one of the kind of free CAD software packages, and it's good for people that are just starting because you don't have to pay anything. It's not like an $8,000 like chunk of money to start. You just kind of download and go. There's Eagle as well, which is super popular in the community, which is relatively inexpensive. But once you get that, you have to get some experience with that. Assuming you have some experience with that, you would enter the schematic and the data from the data sheets. Pull and make the symbols, the footprints. There's a lot that's involved. There's a series from Chris Gamble that goes through like the 101 for that, getting to Blinky. There's a couple of different KiCad tutorials out there on the web. One from Sean Heimel, I think he did one for DigiKey, maybe a series. Just kind of get out there and dig around, find kind of, usually the complexity of the circuit really is kind of grows with your experience. So when you first start, your ideas probably won't have too much going on, but if you do, you might want to find somebody to help you out, essentially. So if you find somebody in the community that understands the technology, can work with you, mentor you through it as well.
We'll be posting Michael Welling's personal phone number and after the call. Check the description below. No, I'm just kidding.
Yeah. But actually, on that note, I wanted to say, Michael, perhaps later you could share with us the links to these things that you're saying, and we could post them in the description, because I think that would be super useful without your phone number.
Yeah, I don't really give out my phone number. My email is.
I froze. I missed what Alessandro said. I don't know. My internet froze for a second.
It's okay.
Oh no, I said it's okay. We said that we're going to share your phone number.
Yeah.
Robert.
Oh, okay. Yeah. I'll just forward it on. But no, so that's awesome. That's awesome. Now, I mean, I don't know if we want to. I know because you've prepared a bit of a KiCad demo for us, right? Like a showcase. Do we want to dive into that, or do we want to keep talking about the process and kind of cut it and then continue on to supply chain and stuff like that after?
I think that we could probably come back to like showing off KiCad. I'm not going to actually design anything. I can show a design, like
okay,
and I can show the hardware that's associated with the design.
Oh, cool.
I think that'll probably kind of be more cohesive if we did it all together.
Awesome.
Yeah, sounds good.
But,
sounds
yeah.
good. So one thing, just to replay back the last two steps, right? So you said you basically you come up with this prototype that's based on a development board, right? And then the next step is, okay, now I need my own board. So you have to kind of go down and like actually design your board. And I was curious, actually, when do you actually share with your potential customer or friends or whatever, like the actual prototype? And when do you do it? Do you do it at both stages, or do you do it just at one point or another?
Yeah, it depends on how you want to roll. Personally, I share the entire process. I'm not one to kind of do the secret project that just magically showcases like at a maker fair, like a lot of even the open hardware guys will do that, where they'll work on something, I mean, for a long time, and they won't talk about it in general public, so that they have this kind of, this big reveal. And I think maybe it's kind of a marketing thing, but when you do that, you're kind of limiting the community involvement a little bit, especially with open hardware projects. So I tend to say, okay, I'm working on this, sometimes I even want to get like a group together, or, have at least like a form of feedback while I'm working on it. So I tend to start early and kind of show my progress, but other people will say, just work on it, and then they'll throw it over the fence and say, here, I have this feedback now that I've already I have a prototype that's actually, like a first level alpha prototype, which would be assemblies or something like that. Yeah, it really depends on how you want to play it. If it's got any secret IP on there or anything like that. If you're doing something that's going to be kind of like going to have trade secret or patentable ideas, usually you're not as open about it. But it really depends on your design philosophy and what you're trying to accomplish with the hardware. So
awesome. Thank you.
Are you usually taking contributions during that process? Like if you're opening this, I don't know, putting your files on, I don't know, GitHub or something. Like, are you taking contributions and issue tracking and doing that whole thing?
I do. It's usually kind of like most of the time, because the hardware is a very personal process, but you can, like, some projects actually will have outside contributors, and like you'll see the occasional merge request on your design. If you pull together a team, like if you're building something with a team, you actually do collaborative work, and that, like the Open Hardware Summit badge was a collaborative design with myself and 3-4 other guys. So that is a completely different process, and you have to kind of try not to step on each other's toes.
Yeah.
And get things done at the same time. Usually what happens is one person takes the lead and the other people are there for support, review, stuff like that. For this design, the schematic was done by another engineer, Alex Camillo, and he was kind of running into some, he had work issues, day job issues, he had things to do. So I had to step up and do the layout for it. And really I was there for support more. And then I ended up being kind of like the main engineer for the layout. And then from there, we had a lot of guys like come in and do review. This is an interesting project. And I think that it had a good flow in terms of community involvement and everything, but it's Open Hardware Summit badge, so it's got a lot of community sauce.
Do you want to share that? I mean, like I'll make the screen go bigger. Yeah, go on.
Real quick though, like because he did touch on exactly this question from Puma 5K. I just want to get this question out of the way here. Regarding open source collaboration and sharing projects and or building it behind the scenes, then publishing it, right? This one is from Puma 5K. The first question that came up at the beginning of the show, we just happened to hit it right now. If one intends to design their own hardware and that development is not an open design, but a design which would be linked to a patent or patents to be submitted, how would that be represented? If that question makes sense.
Yeah, usually that's a completely different flow. Usually you do eventually, I mean, like with a design like that, usually there's going to be kind of contract engineering involved, probably. So what you'd end up doing is finding a design firm or, somebody like me, a freelancer. You sign an NDA and then you say, okay, here's the specs, build it to the specs. Or if you want to design it yourself, and you need design review, there's some places that'll do that, but it's harder to get design review done on a proprietary design because you have to find somebody that just does contractual design review, which is kind of not a big thing, I don't think. So usually what happens is you'll go to a contract engineering house, and what'll happen is they end up doing at least some of the legwork, like figuring out part sourcing and stuff like that. So yeah, it's not the same process at all. It's very kind of NDA written and, super secret, behind the scenes kind of stuff.
Awesome. Yeah, thanks. Sorry, Alessandro, for stopping that. I just felt that was kind of like the perfect
That's
spot,
absolutely
right?
fine. Good that you remembered, actually. Good spot. It was right on what we were speaking about. So I was saying, Michael, you were showing around something that you showed us before the show, right? Yeah. So I was thinking perhaps you want to introduce what that is, and I'll put you up as like you on the screen so you can show it as a close-up. So yeah, I'll let you do that, then you can talk about.
Okay, so I alluded to this board, which is the Open Hardware Summit badge for this year, which went virtual because of COVID-19. So there are like 100 or maybe 300 of these sitting at NYU in some lab that we can't access right now. But this was a collaborative design effort between myself and a small team, including Drew Faustini, and the design engineer. I think their names might actually be written on the board. I don't know if you can see that. Yeah, not really. The autofocus isn't working so hot on my mic. Yeah, it's focusing on my face still, but we had the two main engineers, and then we had 3 support engineers, and then what we originally did was we met up at the Hackaday SuperCon the year before, and we actually sat down with some of the the Badge Life crew, Drew's friends, just anybody, big names that you can think of in the Badge Life crowd, and they were just talking about what is good, what's bad, what things to avoid, and this guy, we targeted CircuitPython, and I think the idea with that is just ease of use and ease of modification. This is actually mainline CircuitPython. You can download the UF2 files for it directly. It is like the Clue. You've seen the Clue from Adafruit. It's kind of like the same thing, only smaller form factor, and it like this folds on top, and it's like a wristwatch. It was going to be the top of the badge.
So it's actually a badge that's not a badge because it's a wristwatch, right? So that's awesome. It's actually the first time I've never seen that before. I mean, you were saying it's got it's touchscreen, right, as well?
Yeah. Well, actually, I'm making a revision of this called ChronoPy, which is because we put a lot of design effort into the thing, and we didn't want to waste all that time. These are probably going to be used next year, or the ones that are in New York are actually going to get sent out to the virtual participants whenever they can get to them. But yeah, what I did is okay, I spent a lot of time on this. Let's actually make it available to the community. And what I did is I'm going to add the capacitive touchscreen, which I really need to get back to this project because I made some promises, and I have a lot of projects, so it's hard for me, but it's one of the initial designs for the thing called Hackster Launch, which is a crowdfunding thing. But
oh yes,
yeah. And
so are you actually on that? Are you there featured as a project on Hackster Launch? Oh,
yeah.
Nice.
Yeah, it's
awesome.
ChronoPy on there. It's actually got this board with the wristband showing in there somewhere. It's an early prototype, which is pretty much the Open Hardware Summit badge. And then my idea is to make an enclosure, which is something that I usually don't do. And this is a big piece of consumer product design, is the mechanical stuff. So I'm going to I'm going to cut my teeth with this project a little bit. I do help with mechanical stuff. I mean, I've obviously designed the boards to the mechanicals, but I usually don't design the mechanicals like the closure and the buttons, external facing interfaces on the enclosure. I usually design them for, what they, wow, what is that? There it is.
Michael, if you launch that at the Hackaday SuperCon, I'm pretty sure, from the whole supply frame where they host it and everything next year, man, you could probably get all sorts of people designing enclosures for you there. They'd probably have a blast.
This is already open hardware, and there is enclosures for it. But the thing, right now, this guy it's a little large. I don't know if you could tell, but it's kind of big on the wrist, and that's because we made it. I think it's 1.5 inches by 1.5 inches or something like that. But I was thinking of making it a little smaller and making the enclosure a little nicer. The thing is, with this current design, we had some screws that came into the back here, and then it had a base plate that you put on there. I don't know if I have one here, but the base plate was pretty much just a mechanical piece of PCB that it was mounted to here, and then the strap would feed through the base plate, and there was open circuitry. It's not something you'd wear out in the rain, or your wristwatch would be toast essentially. So there was a 3D printed designs. They were created, and there's all the 3D models and everything were added to this guy during the process of creating it.
Let me ask a question here, because this kind of still fits back into the whole big picture. What was the cost of all of those parts building that device there?
This guy,
I'm not talking not like time and engineering efforts. I'm more referring to the actual
cost of goods sold.
Yeah, cost of all the components and everything.
I'm thinking because we use some high-end sensors on here, and I haven't done BOM optimization on it, but it's probably close to, like, one-off would probably be close to maybe $40-$50 or something.
Oh, that's not bad at all. Okay.
It's not cheap though, because then you have to mark it up for selling it. So what I typically do is I take the 1K or depending on what the volume is, you take that price to figure out kind of where your ballpark starting point is. You take the COGS, you multiply it times a factor. Depending on who you are, it's 2 to 2.5 times the COGS. I sometimes go even lower because this is just community projects. Like some of the other designs that I've done, I don't think it was that much. But the thing is, when you go to sell them, or when the resellers want to have a certain margin, so you have to build in quite a bit of margin on the boards for that. So it's tricky business when it comes to that part, like towards the end of the design. This right now, this is not a product. It's more of a eval board, and it's the way it's going to end up on the site. It's going to be an eval board because it's got Bluetooth on here. I don't want to go through the FCC certification. It's going to be a small batch engineering project, and it's not going to be a huge money maker for me. It's more of a nicety to the community. Hey,
Yeah,
it's
fun. It looks like a fun project. I mean, I wouldn't mind trying it out myself.
Yeah, and if you registered for this conference, you're going to get one eventually.
Okay. Well, we should share that link maybe. But so Michael, I want to get another question in here because this is kind of somewhat fitting into talking about your personal projects right now. And this one is from Carlo on YouTube. He's saying, Michael, have you ever tried to make a product, then hit a technical challenge that you could not overcome? Or are you good at being able to tell in advance if the idea is feasible?
Yeah, this comes with.
And give us an example.
Yeah. So I worked on a project that was trying to do a sense. It was kind of a day job thing, but they wanted to do something that was borderline impossible. They gave me kind of a very loose spec before I started, and I should have pushed back a little bit. And what happened is the project came through because I was in a kind of a lull, and I needed some contract work, and I took the project on, and then I finally get to understanding the real specs, what they really needed, and it was something that was not possible with like the current technology. I mean, they kept pushing back and saying, okay, just make something. And I eventually get to the point where it's like, the Bluetooth bandwidth wasn't sufficient to send all the data that was needed over in a reasonable amount of time. And I just said, hey, we just need to wipe our hands clean of this project. It's really good to know the exact specs before you take a project. So this is a life lesson there, but it happens. And over time, you kind of get an idea of what's going to work and what's not. But there's always things that come up that you wouldn't foresee. So that's why you do those early prototypes. If you don't know for sure that if it's gonna work like in production, you'll probably realize that along like somewhere in the early product or prototype phase.
I think that's a big lesson to kind of maybe spend just a half a minute or a minute on here, because a lot of times in engineering, you're presented with a project or even just a deliverable, something. It might not even be hardware design. It might be a piece of code. It might just be something that you have to deliver. And as you kind of are in this world, working in industry or research or wherever it is, over time, you kind of start to realize that you need to provide yourself with this buffer period, right? And so like I say, oh, I'll have that ready in 8 weeks, or I think I'll have that ready in 8 weeks. But in reality, it's not really 8 weeks. You want to give yourself a little bit of a buffer period in case something goes wrong, because things go wrong. It's normal. And so you need to factor that into your workflow.
Yeah. You remember on Star Trek, there was Scotty always like drastically overestimated the time that was required for a project kind of thing. This is an engineering thing that you learn over time. You always overestimate, because they're going to be happy that you finished early. They're not going to be happy if you're extremely late, or late on the project. So I take my numbers that I kind of guess at, and you can only guess. There is no exactness to doing time estimates. You take that number and you multiply it by something, so that that you have that little extra time. Maybe I think a lot of times you forget when projects, say you're working with a team, you're handing off projects, there's the learning curve and the kind of getting up to speed. So there's going to be a little bit of there's going to be some slowdown there. And this is things you don't usually take into consideration when you're doing estimates. But yeah, that's something that comes with experience, and it takes years to be able to be good at it. And I still run into problems sometimes where
we are screwed then. There's no chance that we can ever get anything done then.
Yeah.
With all your experience. Now, I was going to ask you actually one question on the community side, because you just mentioned it's about working with others, right? So usually, like, I've been working as an engineer in ARM, and you kind of get to know your team, and you know what their strengths are and what you could rely on, what you can't rely on. Where it's quite interesting when you work with communities, because you don't really know what you're going to get, right? So, and any help, I guess, when you're working on your own, any help is useful, right? But then you got to weigh that with how much time does it take you to kind of spell out what you're thinking of,
ramp up that person in some way.
Exactly.
Yeah.
So how do you go about that? Like, what's your process there, if you've got any?
Yeah, I think it's just kind of like avoiding like toxic contributors or people that are just going to eat your time.
I'm hoping for a specific answer from you, Michael. I'm going to see if you say it.
What do you mean?
Keep going.
Thanks, Robert.
No pressure.
But yeah, it's just what you do is just kind of if they want to contribute, kind of vet them a little bit. Say, what's your experience? If they're asking where I can contribute, they're usually new and they just want to get some experience. So it's better kind of lean them towards something that's going to be kind of documentary or mundane tasks, so they get up to speed. But the thing is, a lot of times these projects, like especially open projects, aren't super complicated. So like we had the mezzanine community with 96 boards, and we would just we would say, hey, come make designs, put them in this repository. And it ended up being me, whenever there would be a group comes in, they're all happy, they do something, and then they just leave, essentially. And it was cool that we had the designs now, but then you have nobody there to maintain the project, so it ends up being on the maintainer, which was myself. And that's the kind of like the community you want to get is the one that's going to keep coming back and contributing to the project. So, and it's hard to find people that have that kind of dedication to an open hardware project, unless they can call it their own. They're not going to want to stick around that long. They're gonna do a little bit here and there, fill their needs and then kind of move on. So it's not like the open source community's got similar types, but it also have people that come back and they have maintainers that stick around for a long time. There's a whole lot more people working on projects when you're doing software than when you're doing hardware. So yeah, I don't know.
You did touch on it, right? So I was going to say, like, one of the biggest things that helps, I think, mitigate the amount of bandwidth that you have to allocate to ramping someone up is good documentation.
Yeah.
If your projects are well documented, if your code is commented properly, if everything is, if the things that you have already done and built up in that project were done in a robust way, then you can pretty much just hand it over to someone and say, here you go, get up to speed. You have 2 weeks. You know what I mean? Like, and you can continue working while that's happening
and run with it. With open hardware, you don't know who's using it, because unless they're like, making a derivative, like a product, or just duplicating it, usually people make a derivative product out of it, or something that's similar. So they take something like the OpenMVCam and they make a proprietary implementation out of it, and it's licensed in a way that
Quabana was talking about that, how there's a bunch of copies of it out there.
Yeah, I've worked on one.
Oh, there you go.
Yeah, but and I got to know him a little bit in the process. And the thing is, though, he has like kind of his core contributors, his documentation is okay enough, or I know MicroPython pretty well, so it wasn't that hard for me. But for other people, I think that if the documentation isn't there, they're not going to be able to figure it out. So yeah, if you use a project a big project like that, like MicroPython, that has a fairly large community, it's a little easier to kind of do forks and mess around with it. But if your hardware runs some, obscure firmware and it's not documented, you may as well just kind of like take it down from the community, essentially, because without documents you can't do much. And I have a problem with that, whereas I work like a regular day job. I run my company during the day, and I do contracting work for several companies. So I don't have a huge amount of time for these open hardware projects. So what I do is I try to document them, but it's probably lacking in a lot of places. So if you can find somebody that can help with any piece of that, you should definitely bring them aboard and get that kind of knocked out.
One question I have on that point: what pushes you? So you've got like a really like a good job that like enables you to pay all your bills. You actually build stuff for your job, right? So part of what I think inspires you is something that you do on a day-to-day basis anyways. So what drives you to actually build open hardware projects that then you share with the community? Not so much because you're sharing them, but more because of the extra work required, right?
Yeah, when I first started, like early on when I started doing contract work, I did the robotics mezzanine for the 96 boards. That was like one of the early ones, and I was on the first episode of
RoboMezzi.
Yeah, RoboMezzi. I was on the first episode.
Were you? Oh wow!
Yeah,
that's awesome.
That was a while ago. I was
Years.
on quite a few of them. I was on quite a few of them, but then I fell off because I was getting busier. But the idea was for me to make the designs so that I could show off my skills for potential customers, and then it turned out I became more of like involved in the community than like I expected. And I've got to know so many people through the process that it's just like, and I learned to like the communities, and I started, it started kind of snowball effect, and I'm not quite to the point where it's like my day job yet, but there are some people to get to that point.
I remember you were, what was it, ELC 2016. I think that was the first time you and I met in person. You were running around the conference hall with, I think, 10 RoboMezzis that you hand soldered, trying to get them into the hands of people who would, of course, showcase your work. And that was pretty interesting
Yeah.
times.
Yeah, I gave one to I think I gave one to you, didn't I?
I never got one. No. I mean, I think David Mandala got one. There was some other people at the conference. Maybe Tyler Baker got one.
Tyler got one.
One got stolen off of the booth.
Oh,
Remember that?
Yeah. The thing is,
we got an interest. Sorry, go on.
any projects that were based on that. It must have been like nobody has spare time for a robotics project that's going to cost them, an arm and a leg, I guess.
Those were also the early days of when I started with I literally started 96 boards that month, right? So I had just gotten hired at Lunaro. I mean, like if Sahaj and Mani were around at those times, like we would have probably been able to put something together real easy, build some sort of drone or something. But then by the time Sahaj and Mani came out, then you have like the AeroCore 2, which surfaced, and other robotic mezzanines that ended up kind of taking precedence.
For a drone, you'd probably want something specifically for a drone, but this is more of a mobile like land or a articulating robot. It had several servo outputs on it, but I never built a robot from it, so
yeah,
I'm kind of guilty as well. It was just a fun project essentially.
Sorry, I didn't want to interrupt.
Go ahead.
But there is an interesting question from the audience that I wanted to share with you. So Puma 5K is asking if you've ever had clients that actually were interested in having a design, open hardware design, and have them basically it would enable them to promote the design and brand. If so, what was the feedback? I mean, you don't have to say names or share anything private, but just.
Okay, so something that's open hardware based, and they want to know it enabled them to promote the brand. So usually when somebody consumes an open hardware project, it depending on the license, if they're selling it, it can end up being forced to be an open hardware project if you use a CC by SA instead of or a copy left type license. But if it's permissive license, they don't have to say anything about it. They could just use it and commercialize it. So if they say, hey, I want to use your product and I want to make a derivative of it, you can get contracting work out of that, but you don't necessarily publicly talk about it unless the client is intending on doing so, essentially. And as a proprietor of an open hardware project, you can change the license to whatever you want, as long as they pay the piper, essentially. And a lot of times, I just it's out there for everybody to use. I'm not there usually to make money in open hardware community. It's not an easy way to make money, honestly. It's actually great.
I guess there's probably another spin to this question. Maybe I'm reading it a slightly different way. I wonder if Puma was also asking whether there is people or companies that think that open hardware could be beneficial to them, to actually having people look at the hardware, the spec, and be able to play with it. Is that something that people could use or companies could use to promote themselves?
Yeah, I mean, Adafruit is pretty much driven on it. I mean, there wouldn't be an Adafruit if there was no open hardware. So there are certain business models that it works for. Like bigger businesses don't really like it very much. Like Intel completely got out of it essentially and dumped like whole divisions. It really depends on what you're doing. So yeah, it's tricky.
I mean, what was it like? Even when we were doing the mezzanine community, we had certain companies, Aero, Avnet, stuff like that, come in and give their ideas and give their thoughts, so that the community would build it and then they could kind of use it, right? I mean, there are models that help these bigger companies, but in general, I don't know if it's them who are actually building it themselves or allocating too much resource to it.
Yeah, I think it's a good way to do initial SoC offerings is to make the schematic and the hardware available to people, because Beagleboard does that. They sell a lot of TI chips because they have an open platform that you can actually reference something that's actually useful, and you can even duplicate the blocks. It's in the design file format. And other things, it's usually a schematic and sometimes a BOM. And sometimes you have to press for the BOM. It's a lot more difficult to do things when you don't have a reference design. Open hardware makes it, if you follow the guidelines, you have the EDA files, the bill of materials, Gerber files sometimes, but you usually can generate those. You have to have a specific, like, there's a checklist for open hardware that I guess some people don't understand, because they'll be marketing things as open hardware, but they really don't comply to the standard. And I think the OSHWA does a good thing in making people understand, what's required for open hardware, and they have a kind of a certification process. And I think it's good to do that if you are doing an open hardware project. It's not required. Like, some people are saying, it's like, oh, it doesn't have the certification, it's not open hardware. That's not true. BeagleBoard was open hardware before, or Arduino, before the certification existed. So that's just, it's like a fallacy. But it's going through that process, you actually do it the right way. And then you have the resources that are provided to people to actually kind of take the design and run with it in a much easier fashion.
So Michael, I'm sorry, we have to be conscious of time here, and I don't want to miss the chance to show your screen. So explain KiCad,
Okay.
or KiCad. I feel like this. I always mess this up.
But
Explain KiCad and all of its subtleties in 15 seconds.
I was gonna give him a minute. You gave him 15 seconds. Wow.
Well, we're over. Sorry, guys.
No, I'm just kidding. We could just go a couple minutes over, but yeah, if you could just share your screen, show us KiCad, show us your hardware piece, and then maybe we get you on in another episode, and we'll call it Hardware 102, and we'll finish the whole supply chain and all that stuff.
We didn't even get into the actual production phases.
Yeah.
There's a lot to go into.
Follow up call.
But yeah, so if you want to share the screen, I can show the design for this particular board. So this is the schematic for the Open Hardware Summit badge. It was kind of a collaborative design. So this is kind of the top level schematic. It is a one-page schematic, which is pretty typical of like smaller designs. It has the BMD 340, which is a Bluetooth-based system on module. It's a tiny little guy up here on the top. And that guy kind of drives the Bluetooth communication and the various interfaces. So you have up here is a power supply section, which has battery management, etc. We have a few sensors, the BME 680. This is a really cool chip, but kind of expensive. Gesture recognition. So this is an IR-based thing. It's kind of cool. We have an accelerometer, gyroscope. I think that's this guy here. The microphone was optional and it doesn't work. So I'm probably switching this to a different type of microphone on the revision. Then there's the LCD. And that's all on this one little tiny board. Usually with designs, you'll add test points for early. So that's what these guys over here, test points. Usually it's either for a pogo fixture, which is part of the testing process, or it's just for early testing with a multimeter. And we have this, this last header was added. We got sponsored by SparkFun. So we added a quick header, which is an expansion header. SparkFun and DigiKey sponsored the whole project, so it was well sponsored. And then we did.
Michael, I was gonna say before you close that, or maybe you could go back to it later. But I was gonna say for people that are not familiar with designing a circuit board, what are the like one or two things that you know like are fundamental that you should think about if you've never done it before? I'm thinking like, for example, the test pins that you showed, right? Like, is there anything else that you'd say like, it's probably not something that you would come up with right away, but it's really fundamental to think about?
Yeah, I mean, when you're doing early prototypes, adding test points to key signals is important. With these particular test points, you see that there's a SW clock, SWIO. This is actually the programming interface for the device JTAG or SWIO. So it's programming interface, and if you don't bring that out, you can't get the initial bootloader on there, and you have like a brick essentially. So before, like when you're designing something, you always want to make sure that you know what the programming interface is and breaking that interface out, or you're going to run into trouble. This particular board runs off of the internal flash of that guy, and there is a serial flash up here.
So can we also, like, because we are going to run short, can we just address iShot JR's question from earlier in the chat here? He asked something about KiCad right here.
Okay.
Maybe we can get that answered by you, Michael, real quick. So he says, so my fear is that you lay something out in KiCad, get the boards made, and then they come back. And only then do you learn that you didn't know what you didn't know. Any suggestions for reducing this? And I think this addresses Alessandro's point, right? Like bringing out these test points and being able to test stuff.
Mm-hmm. Yeah, I think that over designing it in the first iteration of your design, bringing out lines that you don't even know you're going to need or use to test points or pads is a good idea. And usually I do that for early designs. If you don't know it's going to work, making it easy to modify is probably the best way to kind of make that prototype have more legs. So breaking out pins to pads or vias or something that you can actually tack wires to and cut traces. If it's a BGA and you have pads under there that you can't access and you can't wire mod, and you have to like unsolder them, and like this is all beyond most hobbyists, then you're probably gonna have to do a board spin. But I mean, you're almost certain to have one revision with at least one issue on it. This is no matter how many times you've done board design, you're always going to have something that needs to be changed. I mean, I've done like maybe 2 designs, 3, something like that worked first time without any modifications. But usually you have some subtle modifications, and you have to do a board spin. And nowadays it's not that big of a deal, but it's still a costly proposition, and it's a long wait, and people don't like that essentially. But yeah, break out as many test points as you can, space things out, make it bigger than you would the final product so that you can get in there and get to the traces. Things like that will make the first article of the first revision much more useful.
Awesome.
This is great. I think we didn't go through the whole process as there's probably way more, but I think we touched on a few key points that are the kind of things that, if it is your first design, you should think about these things, right?
Yeah.
I think we have two follow-up episodes with Michael, if he'll be so kind to loan us his time sometime in the next year. Hardware Design 102, where we finish the discussion on the big picture and the whole supply chain process, manufacturing, production, etc., possibly crowdfunding. And then number 2, we need to get you on here to do a live KiCad build with us.
I would think maybe an LED. I actually did something here in Reno back a while back, where I actually did a KiCad seminar. This is all day seminar. These aren't short things. It takes a while to get through all the intricacies. So they usually break it down into courses. And if you want to learn KiCad, first you got to learn how to draw circuits. If you want to learn how to draw circuits, then you have to do the basic electronics courses. You have to know a fair amount of mathematics, depending on what you're drawing, logic design, stuff like that. So, yeah, it's a process. I mean, coming up with an idea is easy. Implementing it is hard, essentially.
Yeah.
Unless
So
you know-
you are actually solving, analog circuits and doing these things on paper, like the paper engineering that you learned in school. You're applying it to these hardware designs.
Yeah, usually in analog and power supply design, you have some basic crunching of equations. Usually the data sheets help you out a lot with this. Reference designs help a lot if you're new to the kind of the specific chip. Say you got a new regulator, it has layout guidelines, it has the recommended components for specific things. And this helps when you're kind of new to it.
Very cool.
And I always follow recommendations, and I'm not new to it, so it's just the way to go.
I think we found maybe another episode that we need to do with Michael as well. So iChartGR is proposing Innovation Coffee 201 Intro to Badge Design.
Okay. Yeah, we can show this guy on that one.
Cool.
Yeah, exactly. Oh yes. Yeah, wait, let me put you up for that. I want you to show that. That's awesome.
That's the Linux capable badge that I made for DEF CON. I think it was a year and a half ago.
Nice.
That had a lot of likes on Twitter, I remember.
Yeah, I never assembled it. I've been wanting to do that, but I never got around to it.
Awesome.
It looks like you can put quite a chip on the back there.
Yeah, the system and package guy. It is. I mean, that chip it's monstrous. It's not just a chip; it's the whole system in package. Essentially, the Octable.
Gotcha.
It's the same one that. Well, it's the bigger version of the one that's on the Pocket Beagle.
Okay. Cool. Alrighty. So
Awesome.
are we closing this out, Alessandro?
Yeah, I think it's time. I think we've kept you long enough, Michael. I'm aware that there is a lot more to talk about, and I think I've got a lot more questions I wanted to ask, and I think we're gonna have to have you again if you spare some more extra time with us. So I think let's talk about the next episode offline. But I'm excited to know more and to learn more from you. But that was awesome. Thank you so much.
We have to do one thing. We have to give Michael a chance to do a plug.
Yes.
While I put this up for you, all you, Michael, you get just a quick chance to give yourself a shameless plug.
Oh yeah, well that's me. The Cordy Embedded is me essentially, and my wife does the taxes. But yeah, I'm an independent contractor. I started a company to kind of give it a little more flair. I have a website. I have a Discord channel. I can probably share that. It's on Twitter, somewhere in my feed. I just started it because I started a kind of a lofty goal of making actual silicon with the new Skywater PDK, which is a whole other topic for another time. But yeah.
Cool.
This is me.
Awesome. Yeah, I definitely recommend everyone checking out QWERTYembedded.com. You can go visit that. They have an about page where you can go see all the different things that Michael's doing around hardware design. I believe also there's like a firmware section where you can see all.
My webpage sucks.
There's still stuff to see.
I don't spend any time on it. If you go to GitHub, you'll see all the projects, the open hardware projects that I do. I don't have links on my webpage for them. But if you go to my Twitter at Cordy Embedded, you'll see pretty much everything posted, at least on there. So
cool. Well, I want to do a little plug as well. Someone mentioned it before. There was a bit of a chat around the topic of conferences at one point. So I just wanted to say that ARM has just opened the developer conference in October. It's 6th and 8th of October. So I'm going to share Dev Summit at arm.com. It's
Cool.
It's an online. Obviously, it's all online like everything else, unfortunately. But it's all free, and except for some workshops that are paid. But yeah, I mean, go check it out. I think we're all going to be there. I mean, at least me and Robert are. I don't know if Michael is. I hope you are.
Oh, yeah, I went to the one that was in person in Silicon Valley last year, I think it was.
Yeah, absolutely. It's taken a bit of a spin because it used to be TechCon, and now it's ARM Dev Summit, because the idea is it's more developer focused, so less silicon, more developer.
Cool.
Awesome.
Yeah. Well,
Well,
so
Michael, it was awesome to have you on the show. Robert.
yeah, no, same thing. I just want to say the same thing. Yeah, Michael, awesome having you on the show. It's always good to see you. You and I go back quite a bit now, right? So always awesome to see you and see that you're doing well, and wishing you the best during these times, and hope for the next time that we get together and have a beer.
Yeah, it's gonna be a while.
I agree. Still, I'll hope for it, and we'll have some fun when that happens.
All right.
We should do the next episode. We could do it at nighttime, and we could have a beer.
Yeah.
It's nighttime for you.
Innovation.
It's nighttime for me. Innovation beer.
Yeah, innovation
Awesome.
beer. All right.
Thank you so much. Thank you all.
Bye, everyone. Thank you, everyone, for watching on YouTube. Bye. Twitter.